Hello, everyone, and welcome to the Riddis user group meeting. My name is Joanna Regal from KMJ Consulting, and on behalf of the Eastern Transportation Coalition, we welcome you to the meeting today. We're just going to very briefly go over a couple of housekeeping items. First of all, we're using Zoom webinar, and we'll get to that. It's a little bit different with Q&A, but if you've been on our recent Riddis user group meetings, you already are used to it. You can join the audio either through your computer or through your phone. This web meeting is being recorded. And if you have any questions about the audio or web, you can reach out to Esther Cleet. The chat box is not available to participants. You're going to be using the Q&A box, and we'll talk about that right now. Okay, so to ask questions, you're just going to simply click on the Q&A, type in your questions. They'll be monitored by Denise, Jesse Burke, one of our co-chairs, and myself, and they'll either be answered at the end of the presentation or at the end of the meeting. If you'd like to ask a question verbally, you can raise your hand. We'll call on you, unmute your line, and you'll be able to ask your question. We'll just ask that afterwards, you please mute your line. At this point, I would like to turn it over to Denise Marco. She is the TSMO Program Director for the Eastern Transportation Coalition. Denise?
Thanks, Joanna, and welcome everybody. Thanks for joining us today. I'm looking forward to some exciting stuff that we've got going on. Next slide, Joanna. Real quickly, as of standard practice, my job basically before I hand this over to Jesse is to give you kind of a coalition update. Recent meetings we've had, as you can see on the screen, we had our quarterly Riddis user group meeting in July. We're having it again today in October. Last August, we had our first truly technical webinar. It was called the ABCs of Conflation. What happens when you muck it up? And so we had 3 speakers coming in from Ohio, PennDOT, and private sector to talk about conflation. Those slides are on our website if you're interested in looking at that. The traffic data marketplace, this is going to replace our VPP marketplace. We are in the evaluation stage of our RFP. We've had meetings in August. We've had a meeting in September. We have a final meeting coming up down below in October so that we can, from a technical perspective, select our vendors from our 6 data sets that we're looking at: travel time and speed, volume, conflation services, OD, waypoint data, and freight data. So that's in process, and we're hoping to have a selection from a technical perspective on November 1st. And then we had in beginning of September, the Meet the Work Zone Data Exchange, the WZDX project, which is being spearheaded by USDOT and BTS. Those folks came in a webinar, and we are now capturing some of the ways that the state agencies send data to work zones, and we will work with them on helping them move forward their standard. What we have upcoming, again, as I mentioned, our final evaluation meeting from our four evaluation teams for the marketplaces in October. We have October 7th, a coalition, what's called a mapping workshop. It's a technical workshop where we are looking to develop some of what we call the features for data fields for third-party mapping applications. That's a mouthful. It's a member invite only meeting, but it's designed to see if we can move forward towards developing some sort of common features that we as agencies can send to third-party apps like Apple, Google, etc. There is a new signal technology and new maintenance needs webinar that's going to take place on November 1st. That's really based from a connected vehicle standpoint, and that information is on our web as well. And then the TDADS is the traffic disaster and it's the congestion pie chart. Let's put it that way. We're doing our final national webinar. The tool has been built. The data has been loaded for all 50 states so that a state will be able to go in and look at national congestion from a national perspective, but then also look at their state as well as some of their counties. So that's if you are working with congestion management or any sort of congestion planning, that's a webinar you don't want to miss, because that tool is going to be available to all 50 states. It sits on top of the Riddis platform. I think it's very cool. Let's put it that way. We have the final 3 things. We have a Waze, our biannual working group meeting with Waze, the product team and the engineering team. They're working on some product features for that tool. We're working with them on providing the feedback and the input to improve that tool, their own tool. We have a New England Hogs Exchange. We're starting up the hogs again. This is an incident management based kind of group. We're going to be looking at service patrols, regional service patrol procedures. We're looking at truck navigation and road and weather operations there. And then lastly, we have our traffic data marketplace biannual state point of contact meeting. This involves more of the data sets that we're working with. That was a mouthful. Gosh, we got a lot going on. Please let me know or send me an email if you're interested in getting more information on any of these. And so with that being said, I think I'm going to turn it over to Jesse, I believe.
Thanks, Denise. Always a lot going on. Great to see all these activities. Next slide. First of all, just thanks everybody for joining us for another great Redis user group meeting. As always, we have a lot on the agenda, a couple of great spotlight presentations. We're going to have some updates from Matt about our Redis product enhancement working group. And then John Allen is going to pinch hit for Michael Pack. Unfortunately, Michael got called away at the last minute, so he's not able to participate today, but I'm sure John will be able to cover everything. So he'll be covering the usual PDA suite, Redis tools and enhancements. Also, the PDA suite performance measures working group had met recently, so John's got some updates there. And then we'll do the usual agency input session. So please think about questions as you're listening to all the various presentations. Feel free to put those into the Q&A or raise your hand so that we can have some discussion when we get to the end there. Next slide. So just to introduce today's speakers, as I noted, Michael Pack is not going to be able to join us today, unfortunately, but we do have Dr. Wang Zhang, who is the Transportation Data Program Manager at the Maricopa Association of Governments. He received his PhD in civil engineering from Virginia Tech in 2006. And for the last 15 years at MAG, his work has involved transportation data collection and processing and applying data analytics and visualizations to system analysis, transportation modeling, and planning studies. He also has experience in leveraging a wide span of transportation and mobility data, and we're excited for his presentation today. We've also got Charles Latimer from the CATT Lab. Charles works for CATT Lab, as I noted, where he helps transportation agencies improve communication through better data visualization, which I think is a bit of an understatement. He's pretty much a whiz at this. His roles at the CATT Lab involve promoting user-focused enhancements to the Redis suite, and also shepherding the development of some of the Redis signal analytics platform tools. Between his time spent with the CATT Lab and the private sector, Charles has over 18 years of experience in transportation data and intelligent transportation systems. And he also serves as vice chair of the TRB Standing Committee for Visualization and Transportation. Also with us today, as always, is Matt Glasser, one of our co-chairs here. Matt's Georgia DOT's Assistant State Traffic Engineer over statewide interstate operations. He started with GDOT in 2012 in road design, and then moved over to the Office of Traffic Operations to work in the ITS systems group. And while in the ITS group, Matt expanded his experience managing, planning, and reviewing ITS deployments, also overseeing statewide ITS comprehensive maintenance contract. And before taking on his new role, Matt served as GDOT's Regional Traffic Operations Program Manager, where he and his team developed nationally recognized arterial operation strategies and performance tracking systems. These enhancements help GDOT and its partners deliver successful traffic operations for Super Bowl 53. No small feat there. Matt has a bachelor's in civil engineering from Georgia Tech and is a licensed professional engineer in Georgia. Last but not least at all, we have John Allen. John serves as liaison and educator for the Center for the CATT Lab at University of Maryland. John also assists in user experience, user interface development, QA, QC, manages special projects, aids in developing strategic directions for Riddis and the Probe Data Analytics Suite. And he's also been a facilitator for a number of different organizations, including the Eastern Transportation Coalition and partners in using archived operations data, for those of you who remember that one. And thanks, John, for pinch hitting for Michael today. Next slide. Just want to thank everyone for participating today, again, it's great to see as we continue to have so many participants from really all around the country, not just on the East Coast, but really all throughout the United States. So thanks everyone for joining us today. Next slide. And I think with that, I'll turn it over to Wang for his spotlight presentation.
Thank you very much, Jesse, for the introduction. And again, thanks for this opportunity provided by Eastern Transportation Coalition and CATT Lab to let me share Mac's experience of using the Redis product in our transportation studies, in our planning process, and as well as modeling process. So with that, let me go ahead and turn off my camera to save some bandwidth, and I'm going to share my screen. Okay, everybody can see it?
Yes.
Okay, so for the next 20 minutes, I'm gonna mainly talk about just a few things. You know, what is Mac, simple introduction of that, and how we use the PDA suite provided by CATT Lab on our daily business. And I want to share our experience with using the platform by giving out some summary of two examples. First is the freeway study. We conducted before and after study, mainly using Riddis platform as a main data source. And we also have been using the website for our regional traffic monitoring. So first, just show where we are. We are the MPO and the Council of Governments for Phoenix metropolitan areas. So based on the latest census, our population reaches almost close to 5 million. And within the entire state of Arizona, we account for about 2/3 of population and 3/4 of the jobs within our modeling boundaries. And we have contained 2 counties and 27 cities and 2 native nations. And we have more than 100 days per year with a high temperature reaching above 100 Fahrenheit degree. So how does transportation work at MAC at the MPO of the Phoenix region? So we have 2 divisions set up. One where our program sits in is called Regional Data and Technical Hub. So we basically do all kinds of technical services and programs, and we collect the data, we process data, we analyze the data, we develop the analytics, and we also maintain different kinds of translation models, and then we provide all those kind of information and the data services to our planning and the policy division, which they handle transportation planning and the policy, and they handle how does the fund tied up to the specific transportation projects. And essentially, we're trying to work together to do data-driven and smart decisions to assist our regional transportation planning needs. And within our transportation technical and service divisions, we have maintained a large different kind of database in terms of the transportation. So there's a traffic data, there's travel data, there's like a transportation infrastructure data, all kinds of data. And what has been contained within the Redis platform, it kind of covers different areas of our traffic data, the speed, the travel time, etc., and we use that on a daily basis. And here in the next, I would like to share 2 examples with you all. So first of all, still one more slide in terms of in general how we use the Redis and the speed data and travel time data from INRIX. We do our system monitoring, we do our quantitative unit analysis. We utilize different kind of tools provided by the website to do the system scanning of the bottleneck, to identify the bottleneck. There was one work done, I think it was 5 years ago, where we did not believe the bottleneck module within Redis was available back then, but we're able to just utilize INRIX data from NPM, speed data from NPM RDS to do the system-wide bottleneck scanning on our freeway system and to do the specific measurements of those bottlenecks and even identifying the cause of the bottlenecks. And for the last 3-4 years, we've been heavily utilizing, the Redis functionalities to help us conduct analysis such as before and after, and to do the cost benefit evaluation for certain studies. That's also kind of regular practice we utilize. And we use the speed data for our model calibration and validations. We build our own performance measurement sites and heavily based on certain data provided by INRIX, and we'll also conduct the trend analysis. So in the next, I'm gonna just break down two main examples. So first example is how we monitor the congestion change on our I-10 freeway corridors before and after a new freeway, which we call South Mountain Freeway opened. So this was a study we did in the beginning of the 2020, even way before the COVID started, because this new freeway opened in December of 2019. And back then, our plan was to continue to monitor the traffic on both corridors and, just to let the things pan out for the next, 12 or 18 months and do a full blown of the evaluation in terms of how does this new open freeway impact our I-10 corridor and in the sub areas. So that was the original plan, but the whole thing, as you may know, got interrupted by COVID, and the traffic wasn't settled after 2 months of opening, and then the COVID started, so we had to postpone it. So what I'm going to talk about today is just some preliminary work we did in January and February of the 2020, even before the COVID started. I'm also listing the 4 major modules and the functionalities we use from Redis platform for this before and after study. So here's a map showing the I-10 corridor in yellow, which is a major freeway corridor, as well as a truck corridor for lots of the trace-based trips in our region. And that has been heavily congested. We have quite a few, large and notorious bottlenecks on the I-10 corridor from East Valley to the West Valley in our region. And, in December 2019, as highlighted in light blue, this new South Mountain Freeway, the last section of our Loop 202 system, open to traffic. I remember it's December 23rd of 2019. So that's kind of in the holiday season. So the goal, like I said, is just to monitor how does traffic change on I-10 because of this new opening of the Loop 202 freeways. And we try to evaluate, its impact to that in terms of congestion, and we try to monitor it as much as we can. So the work I'm trying to tell you, obviously, is not complete because we only get to look at the data for the months of January and February of 2020 before COVID started. But this is kind of the overall impression. We were using INRIX or CATT Labs user delay cost analysis just to calculate the cost of the delay on I-10 before and after the new freeway opened. So as you can see, the time axle from left to right, and the blue line identify the date where the traffic opens on South Mountain freeways. So this is actually showing the congestion cost estimation on I-10. So we have different kind of level of the congestion before and after. So this is during our peak season. So except for the last 2 to 3 weeks and maybe the first week, at the end of the 19 and at the beginning of the 2020. But the rest of the time, our peak seasons, as you can see, our overall entire I-10's traffic delay has reduced by about 35%. And then, we just look at that in more details by time and by specific segment. In this case, will be TMC for before and after. We're able to just quickly download the data from the platform and utilize that to plot this kind of heat map, just to see where does speed improve, where does the speed get worse. So obviously, you see more green after the South Mountain's opening. So everything we're looking at is not for the new freeway, but for the I-10 corridor. And then this kind of show you on average weekly basis for 5 months, October, November, December, which we treated as before, and January, February, which we treated as after. the opening of the new freeway. So we can also look at this, for different day of the week from Monday to Friday, which is on the top as a Monday and on the bottom is a Friday. So you can see the area of the concentration of the reddish, which is the congestion. How does it evolve by any given day of the week and any given month? And also you can see the area of the concentration shrink after the opening of the new freeways at the specific areas. And then this is just calculating the delta of the travel time and the delta of the average speed on link level, on TMC level versus time for the entire item in the corridors. Obviously, this is only showing one direction, but we produce that for every particular direction as well. So in this case, actually, you're showing there's a certain areas on this item corridor. Their speed got improved, their travel time, there's some certain travel time saving as well. But there's also areas, we're seeing a little bit more congestion as I'm circling right here at the bottom of the screen. So that is where the I-10 and the connection and its connection to South Mountain is constructed. So we had a new T-shaped, freeway interchanges start to open to traffic for 2 months. Is actually create a new bottleneck for us in that particular areas. And another functionality we use, if we can play that, is just to use this trip map functionalities. We really like that. We can see how does traffic change over time. We can see different time and different months. So this is also a tool we use a lot just to share with the stakeholder, give them some simple and straightforward information regarding how does traffic has changed on I-10. And then certainly you can pause anytime. You can do some more, detailed, observations. For example, we're looking at a particular corridor on I-10 and try to show them what is the specific speed improvement after the new opening of the freeways. And you can see the average speed on this particular segment. At the before is about 18 miles per hour and improved to about 35 to 38 miles per hour in the last 2 months before COVID. So we analyze that any given bottlenecks, and there's another case which you don't necessarily see any changes on I-10, even whether it's before or after the freeway opens. So it kind of remained the same, and at actually particular months, the speed actually decreased. So that's another cases where at the I-10 downtown of Phoenix, we see the improvement of the congestion. So the average speed, was able to improve from roughly 12, 13 miles per hour to at a close 30 miles per hour. So your travel time saving at that particular segment could be doubled. So these are all using the train tools, like I mentioned, train map tools. And there's a particular stretch, like I mentioned, we created a new bottleneck, and actually the traffic congestion increased at this particular stretch of the I-10 in the West Valley on the westbound. So the speed dropped from above 30 miles per hour to below 20 miles per hour after Loop 202's opening, because there's more traffic introduced into the I-10 westbound from southbound freeway. So that's kind of the quick overview of the example number 1. And example number 2 is, ever since COVID started, we had a need to kind of monitor our system's performance in terms of its congestion. We know everybody was stuck at home at the beginning, nobody was travel. You can get to anywhere in the valley in a matter of minutes because you don't hit congestion at all. That's the situation, in late March, April, and maybe early May of last year. But ever since then, our traffic delay has been coming back. So we've been utilizing CATT, products specifically for the user delay cost analysis as massive data downloader. There's 2 functionalities to help us monitor the traffic conditions on our freeway system through COVID. So we're able to build this kind of infographics. As you can see at the very left side, that's kind of the normal condition. We treat the first week of March of 2020 as a normal conditions. So this is try to evaluate the entire freeway system's congestion delay, and as you can see, so we pretty much don't see anything for the next 2 months after COVID started, and then it's gradually coming back. But in our region, it's actually going back very slowly, even up to the last couple of weeks. What we have observed, for example, at the end of the August and or beginning of September, we only see about 55 to 60%, 55 to 60% of the traffic congestion as it compared to pre-COVID. We try to understand the reason of that. That's another beauty of this system. We can, look at them in different kind of time period. So we can build this kind of trends just for the AM peak in our case, which is 6 a.m. to 9 a.m. Our PM peak is about 2 p.m. to 6 p.m. So we're able to look at the congestion trend by a certain time period. As you can see, the blue is AM, the red is PM. So our AM congestion was largely gone all the way till this past July. And once our school started to begin the in-person session and the university opens, and more and more people shifting from work from home to working office, we start to see the hike of the AM congestion. So to a large degree, when we see the reduction of the congestion on our freeway system, it was largely due to the reduction of the congestion in the AM. But for the last months or so, we've been seeing the AM congestion coming back really quickly. So we're going to our next peak season in our region in fall. So we can closely monitor our traffic conditions utilizing Riddis, because you get what's going on 30 minutes ago. So it's really convenient for us to do this monitoring. And we're also able to just download the whole region's data and try to look at average speed changes through from the beginning of the COVID on monthly basis by facility type, freeway versus arterial. That's gonna help us answer some question. People ask, do people travel a lot more faster these days since COVID? We can use that as a response, even though we don't necessarily look at the very first tier of the fast speed, free flow speed at the very top. But overall, we don't see much of the increase of the speed, and that small amount of the increase of the speed, to my opinion, it's more towards the reduced congestion. So kind of summary to the two examples as well as other stuff we've been doing with Redis, here. So we really feel like it's a great tool to help us conduct mobility analysis efficiently. And it's a really sustainable and equal, system platform. It's really easy to use even for beginners. I have done quite a few times of the tutorial to our planners just to let them know some simple functionalities where they need to do it, at a meeting or by themselves. It's easy to use, and the data preparation is quick. And also, I think we really like the short latency of the data availability. You can look at what's going on 30 minutes ago. So that's really convenient. And last but not least, it's great customer service provided by CATT Lab. We used to have questions, concerns, or we used to encounter problems. We contact the customer service, always got very fast response, and always keep us happy. So really appreciate that. So in the end, it just serves as a really critical information analytics and infographics platform to our stakeholders in max transportation planning and modeling process. So that's what I would like to conclude with. So again, thanks for this opportunity to share Mac's experience using Redis platform. And here's my contact, my email. If you have any questions, feel free to type in the chat. I'll take a look and respond, or just send me the email. Thank you very much.
Thanks, Wang. Great presentation. Lots of different Great analysis there. I don't see anything in the Q&A now. Oh, there's something appearing right now. Good timing. We do have a question from Simona saying, wonderful presentation, congestion, delay, and so forth have volume and speed components. Have you looked at volumes or VMTs specifically to identify how the rebound, in travel times has happened with COVID? Great question. I don't know, is that anything you've had a chance to look at yet as far as comparing volumes on the roads that you've been analyzing?
Yes, Simona, first of all, that's a great question. Thanks for asking. And we do. So we'll be monitoring not only the congestion, but more importantly, number of cars on the road. So our traffic volume on our freeway system, for example, has returned to kind of pre-pandemic level since this past March, and it has maintained at that level for the last 6 months. So that's kind of, interesting thing we're looking at. We have 100% of the cars running on the road, but we don't necessarily have the same amount of or close to similar amount of the congestion on the freeways. So we believe there are two major reasons. First of all, people's travel, patterns have changed because of to a large degree, there's a certain, workforce still doing the telecommuting, and people go to work, go to shopping, go to entertainment a little bit differently these days. Those all contributing to that. Seems like we're looking at a more spread out congestion, particularly in the morning, as compared to the pre-COVID. So that's question number one. And the question number two is, I forgot to mention, is since COVID, Arizona DOT has completed quite a few significant roadway improvement projects on our freeway system, adding additional lanes, adding additional capacities to our freeway system. So you have same level of the demand, but you have even more supply in that case. So your VOC overall for the whole system, dropped. I think that also contributes a lot to the reduced congestion that we observed.
Interesting. Yeah, great question. I think we're seeing similar trends in our area. So something I was thinking about during the presentation, if other folks have done any similar analysis looking at your trends during COVID and where we're at today, feel free to maybe share those during the agency input session. I think we've seen very similar trends in our region where the volumes have picked up for quite some time, but the congestion is not necessarily there, although it kind of depends on the roadway that we're looking at. So unless there's any other questions at this time, I think maybe we'll move on.
Jesse, I think we see another question.
Oh, another one came in. Okay, great. Another one from Tom at DVRPC. So how do you consider non-recurring congestion, things like crashes, disabled vehicles, when you're looking at overall congestion?
Yes, Tom, thank you for the question. It's a good question. We consider everything for this kind of system analysis. We understand we have our, we have this kind of non-recurring congestion happening pretty much every day at some point of our freeway systems. So there's no way you can specifically pick them out and throw them out of the analysis. So, incidents, crashes, those kind of, what we handle every day. So it's all being included. Obviously, when you see the trend for the particular, day of our entire freeway system, you're going to see some spikes. Those are more than likely tied up to a certain, big crashes. So we can look at the data and go back to, our incident database just to link them together. So we actually did that.
Okay. Thanks, Wang. With that, I think maybe we will move on to Charles's presentation. So he's already sharing his screen, so go ahead, Charles. Oh, there we go.
Okay, just a second here.
While he's getting his screen up, another thing to just ask folks to think about for the agency input session is whether anyone else has done similar analysis of looking at like a new roadway or new project that opened and how that impacted travel. So just another thing to think about. But with that, go ahead, Charles.
Okay, are you seeing my presentation screen?
Yes.
Perfect. Okay. Well, thank you, Jesse. So Today we're going to talk about one of our newer tools, signal analytics. And we'll start by giving a brief introduction. Then let me turn my video on here too so I can see me. There we go. Okay. So we'll start by giving a brief introduction and then spend most of our time delving into some use cases for the tool. We'll then wrap up with some new features and about things that are coming soon and hopefully have some time for questions. So signal performance measures have really seen a renaissance in the past decade, especially with the adoption of ATS-PM. Instead of checking on the performance of their signals every 3 to 5 years when retiming is due, agencies can monitor the signals on a regular basis and find problems early before they get out of hand. Agencies who've embraced signal performance measures have seen quite a few benefits from their investments. They can respond proactively to issues instead of reacting to customer complaints. They can time their signals more efficiently to better match the evolving traffic conditions. And they have the data they need to communicate outcomes of their signal timing programs to their stakeholders. But as great as ATS-PMs are, there can be some significant barriers to entry for some agencies. ATS-PMs need a lot of roadside detection in order to be used to their fullest potential. Agencies may need to upgrade their signal controllers. And then there's the data storage and servers and software expertise that can be needed, depending upon how the agency wants to implement. So at the CATT lab, we were looking to do something a little bit different. So instead of taking the detector information at the intersection and then using it to calculate the performance of the traffic, what if we directly sample the traffic and then use that to determine how the signals are operating? So that's exactly what we're doing with signal analytics. So we're using high resolution probe data from a third-party data provider, and we're able to compare how the signals are performing across a wide geographic area. There's no roadside infrastructure is needed. And just like Riddis, users don't need to buy a server or extra software to use the platform. And the approach is scalable anywhere in the nation. So over the next few minutes, we're going to step through some use cases, 3 use cases to show how the signal analytics tool can help agencies manage their intersections better. So our first case study comes from Washington County, Oregon. How are the signals in my county performing? So agencies have asked, is there a way that I can rank the performance of traffic signals across my entire county so I know which intersections to focus on? How can I see how much traffic conditions are changing month to month to see if I'm making a difference, or maybe see if traffic conditions themselves are changing? So one solution that I'm going to show you next is to use the ranked intersection table in the tool, ranking things by weekday split failures. So before we go too much further, what is a split failure? So we have an official definition here, but in lay terms, a split failure happens when you get stuck at a traffic light for more than one red cycle. So for example, consider this line of cars that's waiting for a red light. When the light turns green, the queue begins to move through the intersection. And you notice this red car here, a little slow here, but yeah, this red car here, and he gets stuck at the light. So if this has ever happened to you, which I'm sure it has, happens to me every day, you can just realize how frustrating a split failure can be. So let's dive into here into a live example here. We'll go to Washington County, Oregon. So this is what the query page of the tool looks like. So I'm going to go ahead and draw a circle over the county, and while that's coming up there, you can see we've also got some other tools here too. We can draw polygons, we draw rectangles, and other things like that. So we pulled up about 55 intersections that match our search criteria. We can go ahead and add those to our selection set. Then below, we can then pick a time period to analyze. Pick a start time and an end day. We can select certain days of the week, maybe just weekdays or weekends, and then select our time of day. And you can see we can move this over in 15-minute time bins here to be a little more granular. So if you used the RITIS-PDA tools before, this should look pretty familiar to you. We can also add a title for our report. This is kind of a new feature, custom titles, and we'll talk more about that later. And once we hit the submit button, we get things go out, and then the report comes back, processes the system, the report comes back, and this is what you get. So at the top of the screen here, there's three parts. We see a ranked intersection table. And so this ranks every intersection, approach, and movement within our study area. So you can see if I click on one of these rows here, the map will then move and zoom into that particular intersection. And then I can then come over here and click on this intersection diagram, and then the map will then move around and update and help me keep oriented in where I'm going to be. And I can also then change the what metrics are shown in the diagram, and from there, if I want to see something different. Okay. So the agency used, basically has then used this information to create a top 10 chart. Let's see, let me go back to my, there we go. To basically then create a top 10 chart for intersections that have the largest amount of split failures. And they did this by month here. And they were surprised to see, most of these had the usual suspects, but they were surprised to see this particular one pop up on the list since it didn't have a reputation of really having a problem. So let's see what we can do to find out more of what's going on. So let's go back to the intersection diagram for this particular one. And as you can see, this is for count of split failures. One of these movements is not like the other. So we can, so what if, obviously there's a lot more split failures on this left turn movement. What would happen if I extended the max time for that movement? So the traffic engineer asked the same question, and he increased the westbound left phase 1 max time from 25 to 35 seconds, basically giving 10 more seconds to that movement. And this slide shows the before and after. You can see the split failures on the problem movement went way down. So it went from 39 to 3. And they're much more balanced with those on the other movements. So everybody was happy. So job well done. Okay, moving on to case number 2, use case 2. This one comes from Austin, Texas. How do I compare conditions before and after a signal timing change? So how can I measure intersection performance if I don't have detection on all my approaches? And using corridor travel times is can be good to measure performance, can be good, but sometimes they don't tell the whole story. Are there additional measures I can use? So let's see how we can use signal analytics to compare split failures, control delay, and percent on green. Okay, so control delay. Control delay is the amount of additional travel time experienced by a user that's attributed to the control device, like the traffic signal. So let's say we have an intersection and we want to track 2 vehicles passing through it. The first travels through the intersection without stopping and without slowing down. And so the time that it takes that vehicle to move through, we're going to call that the reference travel time. And the second vehicle stops for the red light, and then it continues on its way. And so this extra time that's spent by the second vehicle is what we're going to refer to as the control delay. And percentage on green, the other measure we'll talk about, this is simply defined as the proportion of vehicles arriving on green. So let's say during our study period, we had 100 vehicles. Each one of these cars maybe represents 10 vehicles. 40 of those vehicles stopped at the red light and 60 of them proceeded through without stopping. So to calculate percent on green, we simply divide the number of vehicles arriving on green by the number of total vehicles, 60 over 100, that gives us a 60% percent on green. Okay, so let's go back to the tool. We're going to give an example here of, so here is Austin, Texas. And we're going to take a look at some signals on McNeil and Spicewood. So let me go ahead and add Spicewood to the mix here. You can see that we have a few extra signals down in this section that we're not really worried about. So we can also use the map tools to draw an exclusion zone around the signals, and we'll take those out of the mix and just go ahead and then use this group right here. So once we go ahead and so let's go take a look at we're going to drill into one of the intersections here. So pick from the map, I'm going to pick this one right here. And as you just saw before, we have the ability to change both of these windows down here. So we're going to pull up a second metric. So we can look at things like control delay and split failure percentage side by side. So after the retiming, you can see that the control delay around the intersection is lower and more balanced. And while the split failure percentage is the side street has also decreased. So we kind of flip back and forth between those two. We'll do our eye test here. So we have before and after. Before, after. You can then download the data to use it for additional analysis. So we could just go ahead and click on this particular icon right here, and then we can download and save this as a CSV file. So here's an example of how. So here's kind of what the file looks like. So here's an example of what. Of how Austin is using the data downloaded from the Signal Analytics tool to do some custom analysis. Kemley Horn's their consultant, and they've built a Power BI dashboard to make the before and after comparison of the signals. So in this case, we're looking at a midday time period, and you can see by the travel times, there's really only like a 1% improvement in travel time. So it's very small, you can't really see what happened. But there's been a significant improvement in control delay and split failure rate. So 36% and 71% reduction, respectively. So the data from the Signal Analytics platform can help the city take proper credit for the work they're doing to improve mobility on their corridors. And finally, we're going to take a look at an example from Rhode Island. How do I spot problem intersections on a corridor without leaving the office? So how can I find which intersections on my corridor need a little extra TLC and which time of day to start working on first? So we're going to use the Signal Analytics tool to compare split failures by location and time of day. So the analysis area here, I was looking at the month of August on Newport Avenue, between Pawtucket Avenue and US 95, just outside Pawtucket, Rhode Island. For this particular use case, I pulled several reports, downloaded the data, and then examined the results in an Excel pivot table. You'll see that. So I started by stacking the number of split failures by intersection according to movement. So I'll give a shout out to Chris Day for introducing me to this kind of a chart. Looks pretty good. It's pretty effective. So immediately I can see there's something going on at Cottage Avenue. And I can also see that because of the orange and the green here, that the problems are definitely in the westbound and southbound directions. So the next thing I'm going to do is I'm going to look at things by time of day. So it's pretty clear that the worst time for the split failures on this corridor is between 4 and 5 o'clock, as can see here by this bar. And it's also clear that Cottage Avenue has about the same number of split failures by itself as all the other intersections combined. So I think I'm looking at the right intersection here. If we then drill down further at the Cottage Street intersection by itself, we can plot the number of vehicles sampled by the time of day, along with the percent on green. So these bars here represent the number of vehicles that were observed going through the intersection from the tool, from the data set. And we can again see that between 4 and 5 o'clock, we have the most split failures, highest volume, and lowest progression on green. So this also confirms this is the time of day to be looking at things. And as a note, just keep in mind that the numbers here that you see here do not represent every vehicle on the road. It's just the ones that were sampled as part of the data set that we analyzed here. All right, so let's take a look. Let's switch over here to the demo. We'll take a look at the intersections here. Here we go. So this is zeroing in on the on Cottage Street, and we can see here we're looking at split failure count and split failure percentage. The You see the split failure count, that's definitely is higher than normal here in the southbound direction, 41 and 34. If we look at the split failure percentage, which is kind of the percent of total traffic that experience split failures, you can see a little bit different story, get a little more nuance into what's going on here. So the this left-bound turn movement is obviously experienced. So about 33% of the vehicles are experiencing split failure between those times. But this westbound movement is also, we're also seeing quite a, it's a lower volume, but a larger percentage of those vehicles are seeing split failures during this time period. So if we go back to the presentation here, we can see that some of the kind of confounding factors here, there are some of the problems that, some of the challenges that the engineers will be facing to be retiming this intersection. So we have the southbound lanes are, we have kind of a shared left and shared right, with the through traffic. So that makes it, you run into situations where the through traffic can back up behind the left turning vehicles. That can cause some split failures. We also see that in the westbound direction, it's a single lane. So all of the movements here, right bound, straight, and through, are all sharing, all have to compete for time. So it's kind of, you kind of expect to see some of the kind of some balanced split failures through there. So if I had a list, if I had to pick an intersection, to give some TLC to, this in that corridor, this would be the one. And I would start with the kind of that afternoon peak period, particularly looking at this left-hand turn movement. All right, so that concludes our use cases. So let's move on to what's new with signal analytics. So I'll kind of go back to here, the demo. So first off, we talked about how we can download data as a part of a CSV file, and we can see here to do that as an example. And we can see that kind of as that loads up, not only do you get the data that you see in the table, but you also get all the other data fields that are available through the platform. So, which is kind of interesting. You can also get you get things like percentiles, as well as just the minimum and like the maximum and average time period. So you'll be able to do some more advanced offline analysis, through the downloaded tool. So definitely check that out with the data download feature. We can also filter signals, in order to on this ranked intersection table, and in order to analyze corridors better. So, for instance, let's say that I want to take a look at all of the southbound through movements. I can go ahead and very easily pick that. And then those are then filtered on the table, and I can sort those by percent on green, split failure, and whatnot, and be able to really kind of understand apples to apples and click through those intersections. And then we can also create titles for notes and reports. And this is pretty exciting. So we already talked about how you can add titles for reports here when you're creating your query. You can also do the same on the once the report comes back. You can click here on the title bar and edit your title, and also add notes as well of what you find. And you can also get to this through the My History page. And this just makes it much easier to find your reports as you go through the list, as you compile these over time. You can add and change the title here. And this notes area, it's more, this will expand to fit whatever you want to put in there. So, if you want to go through and put some detailed notes in here about what you found, like, say, hey, this is what I found, and then you can add some more later. This is how I fixed things. You can do that as well. So it's a pretty handy feature to have. So coming soon, kind of our last section here is kind of one of the next things we're working on are some improvements to the intersection selection screen here. So instead of having to draw a circle around the area to find the signals, those will come up automatically, and you can either use the regular map controls, or you can also click on the signals individually to add those to your selection set. So that'll make it easy to kind of pick, just pick a small group on the map, or pick up a couple that might have been missed by by one of the polygons or rectangles. We're going to be adding a whole bunch of more data fields. You probably saw the ones that were in the Excel spreadsheet. We want to put those allow you to put those into the table at the top of the screen. So those will include the percentiles, minimums, and maximums of the approach speeds and control delays. You'll be able to select those. And then we're going to improve our filtering to make it easier to just to kind of add one filtering criteria at a time. So you can do that, and then add different kinds of filtering constraints like greater than, less than, between, and or, just to make that a lot easier to manage. And finally, our intersection matrix tool. This is kind of a brand new functionality that we're going to be looking at adding. That'll let you build an intersection matrix to create some performance measures heat maps of your intersections, by time of day, day of the week, weekday, weekend. You can then be able to switch your granularity to 15-minute to get some smaller time slices. And you can maybe, if you want to look at things hourly, you'll be able to shift your time bin around. It's like 4:30 to 5:30. If your peak hour is a little bit different, then doesn't quite follow the clock. And you'll be able to click on these arrows around the intersection breakdown to get different POG charts depending on the different movements. So we're pretty excited about that. And that brings me to the end of my presentation. So my email address is here if you have any questions, want to reach out to me directly. But Jesse, I'll turn things back over to you to kind of field some of the Q&A here.
Great. Thanks, Charles. I think we do have one question I think we have time to try to answer real quick.
Okay.
From Luis Velasquez asking, has the split failure metrics from the probe data been validated against traditional detector locations? And can you share the calculations used to develop the metrics?
So I would have to kind of reach out to you probably directly to, I can pull that and reach out with the actual calculations, but the data provider, they have done some analysis where they have, so a part of what they've done is when they've defined their intersection zones, they've tried to do so in a way to be as consistent as possible, to get the results as consistent as possible with what you get from ATS-PM. So they have done validation to tweak things to try to get those metrics as much in line as possible with some of the traditional things. So.
Great. And just quickly, is this a feature that is available to everyone, or is it one of the ones that you'd have to have some level of participation to have access to this tool?
So Signal Analytics, this is a kind of a separate data set. So it's not something that you would normally get just through the standard PDA and Riddis. So it's a special kind of probe data. It uses very high resolution pings. So it's kind of its own. It's trajectory data. So it's its own different thing.
Yeah, just wanted to clarify that for anyone who isn't seeing the tool in their PDA suite. Feel free to reach out to CATT Lab staff, and you can always, there's usually a way to get that installed, but it involves data and funding usually. Well, thank you, Charles. Great presentation. If anyone else has other questions, feel free to continue to add those to the Q&A. But I think we'll move on to Matt with the Riddis Product Enhancement Working Group update. So go ahead, Matt.
Appreciate it. And I think Joanna is going to be helping me move through this. So wonderful. She's already got it up. So thanks everyone. Really appreciate the time. And first, I really just do want to highlight the folks that are already participating with us. Other than myself at Georgia, we have Massachusetts, Oregon, Virginia, and Michigan who've already signed up and either pledged or have given us authorization to utilize their funds for as we mentioned before, kind of a pooled fund effort. And again, I'll probably reiterate this a few times, but as we're moving through this, as you're thinking about things, it's never too late to join up with us. Certainly would love to have more partners in this so that we can push forward new and exciting initiatives every year. So to just recap where we stand right now, the working group that we already have approved the development of 3 new pretty large projects. The first one being the cause of congestion pie chart and the deep dive on that. So I think you've seen this a few times. from Michael and his team. In fact, I believe in the last user group meeting, they demonstrated a few states and what it's looking like already. We'll get into that in a second. We also have some Waze enhancements as well as a new corridor speed graph. So we can go ahead and move on to this next part. So again, just to reiterate, what this looks like. If you're familiar with the cause of congestion pie chart that was built many years ago, this is an attempt to revitalize that and make it relevant to what's going on a day-to-day basis. An effort was already paid for outside of the Eastern Transportation Coalition and the Riddis user group to build these metrics out for individual states, and the hard work and the effort that went into that laid the foundation for what the Riddis enhancement user group ultimately paid for, which was very detailed selection. So instead of having to look at an individual state, which is what we're all used to, on a national level, this brings us down to the state, the county, and even the road level, which is outstanding from an operations and planning perspective. So where we stand in this right now is that the overall software and design work is very well underway. The CATT lab is finalizing. I apologize. My dog wants to say hello to everyone. They are finalizing the user development and working on automating those scripts. And ultimately, we will be working with the user group as well as other individuals to push this effort forward.
Matt, this
Yes.
is Denise. Can you clarify the distinction between the initial work that was done through the funding of BTS and then the additional work that the enhancement group is now funding? Can you delineate the difference between the two?
Absolutely. So, and Denise, feel free to correct me if I'm wrong. But the initial work paid for by BTS was to take the initial, I apologize, let me let my dog out. The original work paid for by BTS was to take what the vehicle probe data that we know and use every single day and move that, basically build an analytics suite and build the tools to ultimately figure out how we could look at this on a state by state level. And so that, as I mentioned, that hard work that went into making what ultimately the user group is paying for was paid for by BTS. What we're doing on the user enhancement group level is taking those algorithms that were built and taking it down to an even finer detail. So again, that's going from the state level all the way down ultimately to the road level that we can use. So we can go to the next one. The next part of this we're really excited about is some Waze data enhancements. Really, that's just taking what is already ingested in the Riddis platform and applying some filtering tools, building it into the PDA suite so that we can do some more sorting with it, and then building it into the event timelines. Again, just kind of making it more user-friendly so that it's not just icons on a map that you can't really do anything with. We really want to take this and be able to make longer term decisions with it. So again, just like the previous tool, the software and design work is already very well underway. You can see that this is, as listed above, is going to impact a fair amount of tools. The CATT lab has already been reaching out to several of our agencies and users to really get an idea of what this should look like, how it should interact with them. So again, that they have a product that's going to work at the end of the day. And then finally, moving on to our last one, if you would, yep, there we go, is just as a new visualization. This is a corridor speed graph that will show the average speeds over the length of a corridor versus different time periods. So in that particular project, they are finalizing the front end design and working with GDOT, who had paid for this specific effort, to make sure that the additional enhancements are meeting the needs. And that development has not yet started, but is expected to begin in about a month. So, as I alluded to at the beginning, there are still a ton of enhancements that Michael had showed us last year, about 15 months ago. And while admittedly, those are just the ones that we know about, this group continues to bring forward new ideas that are not necessarily just for a new analytics tool, but it might be for a new visualization. Heck, I think even what John Allen will be talking to you guys about here in a few minutes, about the templates that we use. There have been a lot of really great suggestions of figuring out how to take the analytics that we do now and turning it into a really nice template, and basically just kind of like we did with the MAP 21 performance metrics. It's kind of just an easy button. Hey, can you do a before and after analysis? And all I have to do is just press one button. That's been a proposal, that's been a suggestion, and I think that's a really great idea. So, if you are interested in joining us, if you're thinking about it, just remember it's never too late to join. I think it's always there's always an opportunity for you to say, I'd like to join a little bit later, or to go ahead and just start thinking about building this into your budget. We've recommended that if you'd like to participate, we've been kind of earmarking about $50,000 ish, and notice that I said ish, for participation. Really, it's just about what may make sense for you on an agency level. So our next meeting, if you're interested in participating, is on December 1st from 2 to 3. Feel free to reach out to Michael Pack, Denise Marco, or myself if you'd like to join, and we'll go from there. And Jesse, I think I'll hand it right back to you.
Great. Thanks, Matt. Thanks for leading this effort. Lots of great work underway there. Again, just a plug for anyone to send ideas along. And if you have any questions that you want to ask Matt that we could follow up later in the meeting, please put those in the Q&A. But with that, I will turn it over to John Allen to give some updates on the PDA Suite Performance Measures Working Group and also the new Riddis tools and recent enhancements.
Great, thanks, Jesse. Let me just share my screen here. Can you hear me okay and see my screen?
Yes, we hear you. Everything looks good.
Great. Good afternoon, everybody. I'm John Allen, work with the CATT Lab and also run the Performance Measure Working Group. We had a meeting last week, actually, to talk about a variety of different things. So let me get those going right now. So we had a pretty full agenda, and these are the things we kind of touched on I want to highlight today. First was our work with MassDOT and their quarter performance reporting template effort and some other things that I'll share in a moment. GDOT, who's always very progressive and coming up with new ways of communicating performance measures, has some great reporting examples that they shared with us, and I'll share with you soon. And Rick Ayers from the CATT Lab has been doing some ongoing Riddis training sessions for different agencies, including how to use the results from the tools and putting them into the templates. If you've participated in some of Rick's sessions, he's terrific at doing that. We'll talk a little bit about that. Give you an update on what's going on with the templates page for Riddis, and then finally touch base on our proposed Riddis virtual training workshops. So I guess about a month ago, MassDOT reached out to us and wanted to talk a little bit about using our templates for some of the reporting that they do. They have a weekly traffic report that they were putting together, a lot of effort and time to do that, and a little technical. So they wanted to see if they could streamline that process and make it a little bit easier for folks like executives and elected officials and the public to understand the results. And they also wanted to take that weekly and make it a monthly traffic report, and using the PDA tools and the reporting templates. They're already very well versed at PDA, but they just wanted to talk about what they could do there related to adding it into the templates. And then Finally, they're looking to create a public-facing dashboard using the Redis tools, and our understanding that's going to be deployed soon. So this is the template that they chose. You may remember this from the Redis catalog that we've shown previously. This is a one-pager, we call it. There's also a standard report that may be made up of like 4 to 6 pages, depending on how many content that you want to add to it. But it's a little simpler to read, a little easier on the eye. We think it's very robust and tells a good story. They have taken this, they're going to work with it and come up with the results. We haven't seen those yet, but hopefully we'll see those soon and maybe share it with you the next time we meet. But what we'd like to do is try to make something a little, give them another option about sharing some quarter performance. So we looked at their old report that was a weekly one. We grabbed one of their quarters out of that and came up with this option. So let me just walk through this a little bit here. So up top here, monthly traffic report, we're looking at July 2021 for I-95 northbound, southbound between these limits. Now, what we did with this report and what Rick has been doing with his reports well is enhancing those with hyperlinks to the tools. So what we say here is if you want to access some detailed results for these measures, click on the highlighted months below, or if you wanted to see an animation of this corridor of speeds over time, you click this button, it would take you to a trend map. So we think this is really going to help folks with explaining information about what's on the roadway, and then linking that to actual content in the tool results pages where you can really get into a drill down if they need be. We also have a box up here that gives you some quarter profile space, so you can put in things like the actual quarter length, cross section, volume, different things like that. So, and then a little box here where you can talk about the differential between the 2 months, June and July of 2021, how it improved. As you can see down here, these are all actual runs of the user delay cost tool, congestion scan, and the bottleneck ranking tool. So these are the results from running those tools. And for example, if you wanted to look at the user delay cost for June 2021, you just click on that and up comes your actual user delay cost results. So you can come down here, you can float over it, you can actually look at other displays of metrics here, person hours, etc. So we think it's a real handy way to tie in your results here to actual Redis results that are much more detailed and interactive, so you can drill down and show other things that may come up with a question. So we think something like this will be very useful. And we've also developed some how-to sheets for doing that. It's real easy. If your agency has Redis and everybody on there, then in your agency therefore can use Redis, they just have to have credentials, ID, password. All you have to do is tell them to turn it on. They don't have to do anything other than log in, and then you send them a sheet and they could use all that functionality there. This sheet here shows you how to do that. This sheet is for doing a trend map for non-Redis users. If you had a maybe a legislator or somebody else who's outside the agency, you can still show them a slightly downscaled version of the trend map. It's interactive, but it takes a little bit different application to make that happen. So we have these sheets that are very easy to follow and you can do it quickly. I want to share a couple of reporting examples that GDOT had shared with us recently. This one is a Labor Day weekend 5-day forecast using the previous year's travel patterns to predict what would happen this year. And what I love about this one is that it's very clean and simple. You can understand it clearly. There's a great use of the colors and the size of the columns and some of the vehicle graphics to really draw your eye to the critical areas of the travel times and the impacts during the week. And it's very clear and concise, not a lot of words, but it really concisely explains what's going on and what to do. For example, you should add 30 to 45 minutes of travel time on the Friday before the weekend. And it's also very media friendly. I searched online and came up with these two media groups down at the bottom here, Fox News and Grace Connect, that had displayed this travel time graphic and talked about GDOT putting this together and predicting some of the travel for that particular weekend. It's a really good example of using that travel information. And then the second one they shared with us was a gradient color scheme for speed differential tables. This is very similar to what Wang had showed for his speed and travel time. And it just really is easy to understand in that it draws your eyes to the darker colors, both the blue and the orange. So you can quickly see areas where you would need to focus on. So it's just a great addition to a standard table that helps you focus in on the problem areas or the improvement areas. As I mentioned before, Rick Ayers has been doing some training for folks. He's done Louisiana DOT, ODOT, New Jersey DOT, my old agency. And I sat in on a couple of his sessions, and he's terrific. He steps through in this example a little bit of Riddis and PDA suite and what it does. And he deep dives into it a little bit and then takes that information and builds on that, taking a particular template and a real world example from that particular agency and building a report. And these are a couple of examples that he used. He likes this particular one at top with the 4 boxes. It was actually developed initially for before and after studies, but Rick just likes the way it's laid out and the information that he can put in the boxes. So he used it for a project assessment report as well as a quarterly performance report. And then also took one of the after action review templates we put together and created this event summary for a vehicle collision on I-10. So a real good job there. If you've ever listened to Rick talk, he's very smooth, seamless, really understandable, great presenter. And every box here is also hyperlinked with some additional information that you can drill down to. I want to give you a little update on what's going on with the Riddis templates page. This is the area of Riddis that we're going to be putting all these templates we have in our catalog, in addition to how-to guides and what we call design sheets. Those are just full-blown custom graphics or tables or charts that are used in some of our templates that you can build right in there and then just copy and paste it into the template. It just makes it a little bit easier to do. So where we are now with this is we have the front end of the Riddis templates page developed. The developers having a little tough time with putting the information from the how-to guide in there. So we found out that this structure would work the best for them. And what we did here was we have, for example, how to make an hourly travel time graph. So you have the step-by-step of using the query screens, what the results would be, a description of that over here. And then these little tooltips we're going to add to give you additional information about each one of these categories as applicable. And one of the things we need to do here is add a little magnifying glass icon where you would click on it and would blow up this particular graphic full screen so you can see the detail. It's just too small when you looked at it in this particular format to see really what's going on. So that's going to help tremendously. So this is the layout they're using to build the how-to guides into the overall templates page. We're hoping to get this done this quarter. It doesn't look like it's going to happen, but we're definitely shooting for the next quarter to get this out. I'll touch base a little bit about our Riddis virtual training group. If you remember last meeting, we had a couple of polls. One was, hey, are you interested in attending a workshop? So 71% of the folks said, yes, they were. If you added in the maybes, it was 99%. And then we asked, which area would you like to see a template session do? And overwhelmingly, I guess, the quarter performance came up as the #1 area what folks would like to understand how to build a template or a report. And that actually was from last year, the #1 area where folks would like to understand how to build a performance report. So we think we're going to focus in on the quarter performance report. So we talked at the meeting and came up with this program outline. It's the first cut. It's very rough. We need to fill in some things and talk a little bit more, but basically we're going to focus in on the quarter performance for a first session, finalize a use case of what we're going to use to walk folks through the whole process of running the tools, getting results, and building it into a report. Finalize what the agenda topics were going to be. A lot of folks, if this is going to be a Riddis user group session, so most folks are pretty well versed in Riddis and PDA suite. We're not going to spend a lot of time on, telling you what it's about and all that, but we'll get probably right into the whole process. And then We think we can do these things in about an hour and a half, 2 hours. Rick Ayers, as I mentioned, has been doing these now for several months. And this is about the sweet spot he found for doing these kinds of sessions. And then while we're doing that, we're going to record these different sessions and build a library of template training. And we'll put that out there on the Redis templates page too. So folks who couldn't make it or maybe join later, the group later on, can tune into those and learn how to use the templates. So that's all about what we've been doing with the templates. Before I move into the stuff I need to cover for Michael, are there any questions?
Doesn't look like we have any right now, John. So I guess why don't you go ahead with the updates and enhancements, and if anyone else has questions, go ahead and put those in the Q&A.
Will do. Okay, so let me talk about the latest of what's going on with respect to Riddis and PDA Suite and trip analytics. So the biggest thing we've been working on and was just deployed was the improvements to the work zone dashboard. So folks may remember from previous presentations, the work zone dashboard is this regional dashboard here, and there's a secondary dashboard. If you click on some of these different work zone areas, there's a what we call an individual work zone profile. Most of the work that's been done up front is related to this particular dashboard. It's an overall cleaner look than previously. It's much more stable. There's less bugs. They did a lot of work in fixing bugs and enhancing the data so that it's very stable. You get all the data all the time. It's great. I've been using it for a while now, much better. The one thing that I think is the overall best improvement is when you select your state, then all your state related information can be shown here all together. Before, you might have Maryland coming up in the beginning, but you're in Florida. You don't really care about too much what's going on in Maryland, so you have to scroll down, bring up Florida, go over to the work zones, top critical work zones, change that up, the map, the user delay costs, all that. So now it's all going to be on your state. Once you set it up, it'll always come back to that state, and you can just go. So it's much better than it was before in that regard. Two other small things was they've changed the map to vector mapping, so it'll be easier to update the mapping for the CATT lab. There used to be a little box up top for you to check either here or Index data sources for your particular state. They took that away. It's just automatic now. And in the future, the developers are going to be looking at the individual work zone profile page and updating that as well. Can't tell you a time frame on that, but in addition to that, there'll be some overall work zone data reliability work as well. So we think this is going to be a terrific tool in the end, and it is a terrific tool right now. I've used it many times. One of the features that they've added here, something relatively small, but I think it's very helpful, was just adding a timestamped queue length under the top critical work zones. So if you hover over this queue length building, which is a 3-hour period, you can see at certain points in time, there'll be a little orange dot. If you hover over that dot, you'll get a pop-up that shows you today at 3 o'clock, there's a 5-mile queue at that particular location. So before it would just show you the mileage. So that little addition of time really helps. Another thing that's been done is adding a day-night mode to personal traffic alerts. So if you just go up here, you slide the slider over from day, and then you can go to a night mode. Great for talk folks and others who work early in the morning when it's still dark, like I do. I just wanted to let people know that on the top of the Riddis bar, the personal traffic alerts is a great thing to use. Don't overlook it. It's a very simple thing to set up, so you can then get alerts on your phone or through emails about incidents or speed changes on a particular road or section of road, or network of roads that you're interested in. It only takes a few minutes to set up a road, and you can just go through, and it works really well, and it's a great feature to have. Some of the data source updates that we've been done is for Oregon. We've added some traffic detectors and DMS on the Redis map. We updated Florida DOT district naming to be more consistent with their convention. And then probably the biggest change here was updating the CTV URLs for better performance and security across all the cameras through Ritis.org instead of the originating DOT. Now for Probe Data Analytics Suite, one of the updates we did recently was adding a chart legend in performance charts when you export an image that is uncustomized. If you remember, if you go to performance charts, you can export it as is, which is what you're seeing here, or you can pick customize, and then you can change everything, basically, the font size, the scales, everything. So for some reason, the legend wasn't coming through on the uncustomized image, and so now it is. And of course, there's all kinds of bug fixes going on all the time with any software. This is just a list of some of the bug fixes or updates that have been done. If you want to see the whole list or you want it more detail, just click on that link there and that'll take you to the PDA Suite updates. So talking about trip analytics, one of the great new features that have been added is when you develop a matrix, you can now click on a button here to say switch to zone maps and do that in one click. And when you push the button, you get this basic OD map here, which is now showing origins and destinations. The origins are in the orange-red colors, destinations in the greenish-blue colors. But what's great is as you click some things like values on map, they all come up and you can see the percentages. You could also do sample counts if you wanted. And if you click on one of these here, let's Anne Arundel, I click on, say, for example, the 12% origins, it'll show you all the destinations for that particular county that we're looking at here. So really great tool, lots of functionality. I haven't used it in a while, and when I did, I was just really surprised about how quick and easy it is. And again, Trip Analytics also has my history. You can actually open your queries, edit them, open or rerun reports and mark your favorites, or you can archive them. It gets to be too many. So again, it's a great feature. I think most people now understand the use of my history and use it a lot. It's just a great way to organize your information. That's it. Any questions? Sorry for the speed of that, but we're running out of time.
Yeah, as always, too many things to cover, but that's a good problem. Thanks, John. I think we are running a little short on time. Joanna put a message in the chat that we are going to leave the Q&A box open for about 5 minutes after the meeting. So, you know, if there were any questions that you still have that we don't have time to answer, you know, feel free to put those in now and somebody will get back to those. But we did have one question, John, that I think we could probably answer quickly from David Heller, just asking if the training from Rick Ayers is available to any agency and also whether there's a fee for those trainings.
There's no fee. I would reach out to Rick, David, and ask him about it. He just did some New Jersey DOT training. Dave's from SJTPO, which is the South Jersey Transportation Planning Organization there. And I know those guys do a lot of good work too, using their own templates and things. One thing I wanted to mention too, real quick, if you saw anything that you like template wise, reach out to me. We'll send you the templates, how-to guides, whatever you need to take it and do what you need to do to evaluate a project or a program or things like that. We're here to help you.
Thanks, John. Lots of good stuff there. I guess while we have a couple of minutes to see if anything else comes in, I think I'm gonna take my executive privilege as a moderator here. And I just had a question going back to Charles's presentation about whether there's any ways in that signal analytics tool to bring in kind of multimodal considerations, you know, so for example, if there's a pedestrian movement, you know, if there's any way to sort of factor those in, or is it really only looking at the auto movements? You know, just curious, you know, especially in our region, there's certainly signals where if you're not looking at that whole picture, you know, you're going to have a difficult time sort of calibrating things. So Charles, if you're still out there, just curious if there's anything you could say about that.
Yeah, still here. So currently the focus we have is really on the probe data, but that's but obviously, you know, you can always add more data, right?
Right.
So that's something that, you know, we can certainly explore, you know, further as the tool is developed more. But
Would that have to do more with like a volume count, or, you know, maybe more information about the signal kind of phasing itself, whether there's pedestrian signals incorporated?
so that would be one way to do it. We would be incorporating, some of the signal timing information, you know, some of the high resolution data, you know, into the platform. There might be even a way to, you know, take a look at some like location-based services data, you know, some cell phone stuff. I mean, that might be an option as well. But we'd have to look into it further to see the best way to do that.
Yeah, sounds good. Thank you. Well, we are at time here, everybody. So once again, if anybody has additional questions, feel free to put those into the Q&A and someone will answer them after the meeting. We'll leave that open for a few minutes. Otherwise, just want to thank all of our presenters today. Thanks to everybody at the CATT Lab for all your great work. And thanks for everybody for tuning in today to another hopefully very interesting session. I know I learned some things as always. So thanks everybody, and enjoy the rest of your afternoon.
Jesse, thank you for being a great moderator.
No problem. Always glad to help, Denise.
See you, Jesse. Good job.
Take care, everybody.